So before we start with coordinate geometry 1, we look at what we did in classroom before we start with coordinate geometry 1 continuation. So coordinate geometry 1 deals with the axis, that is the x and the y axis. And we are also dealing with straight lines too. So the last time we met, so from our previous lesson, we learned about how to find the gradient, distance and midpoint when given 2 points, say A to be x1, y1 and B x2, y2 on a line. So there are 2 points on a line. And then we also derive formulas for finding each and every one of them. So with gradient, we have change in y over change in x, where we have y2 minus y1 all over x2 minus x1. The midpoint, the formula for finding the midpoint is x1 plus x2 all over 2, y1 plus y2 all over 2. Now the distance between the 2 points, this is how to find the distance between 2 points. We have change in x squared plus change in y squared, all square roots. Now today's lesson. Today's objective is by the end of the lesson, the student will be able to find the coordinates of a point which divides a given line in a given ratio. Dividing a given line in a given ratio, whether internally or externally. Okay, so division of a line in a given ratio. Now suppose a point P, which is x and y, divides 2 points A, which is x1, y1 and then B x2, y2 on a line internally in a ratio alpha is to beta. That is to say, alpha is the bigger ratio and then beta is the smaller ratio. Now what we are going to do today is that there is a point P dividing 2 points on a line. Now let's look at the drawing. Now this P is dividing these 2 points, which is A, which is our first point, which is beneath P, and then B, which is our second point, which is above P. Now this P is dividing these 2 points, and as this P is dividing these 2 points, it's going to divide A and B into 2 ratios. Okay, so internal division. So now let's look at the diagram once again. So from the diagram we can see from A to P is alpha, and then from P to B is beta. Now from the diagram we can see similar things, and we can see things which are common, and that is why some I have used red lines to indicate, some I have used blue lines to indicate. So in the diagram we have APE, the triangle APE and then the triangle PBC are similar. So when we say similar, it means that they have the same length. That is similar. So they have the same length. So since the point P is dividing the point AB on the line in a given ratio, this is how you write it. So since P is dividing AB on a line, it's going to be AP is to PB, because we are dealing with ratio. AP is to PB. What does it mean? It means that anywhere you see AP, you are going to replace it with alpha, because from A to P is alpha, and then from P to B is beta, and that is why I used AP as a red, and then I used alpha to red, PB as blue, and then I also use the beta 2 as blue. Now one thing you must also understand from the diagram is that where the red lines are means that they have the same length. So from AP is the same as from A to E. From A to P is the same as from A to E. And also from P to B is the same as from P to C. The distance from P to B is the same as the distance from P to C. So therefore we can also write it in this form. AP over PB. Anytime you see a ratio which is to, it means that you can also write it as over. So AP is to PB is the same as AP over PB. And then we also said AP equals AE, so AP equals AE. And we also said PB equals PC, so PB equals PC. Okay, so but before you can find your AE, the only way you can find the coordinates for AE, you must use the point A and then P. and the only way you can find for PC is to use the point P and then B. So when you use the point A and P, you are going to get x minus x1 found for AE, and then when you use the point P and B, you are going to get the coordinate point for x to be x2 minus x for PC. So now we know all these things. We know AP to be alpha from the diagram, we know PB to be beta, we know AE to be x minus x1, PC to be x2 minus x. So we are just going to input them. So anywhere I see AP, I put the alpha. Anywhere I see PC, I put x squared minus x2 minus x. So when you input your values, this is what you are going to get, or you input your data. So now we have x to be common term, so we are going to make x the subject. So when you make x the subject, this is your final result. So making x the subject, we have x on both sides, you group them, then you make x the common factor, you bring x out, and then you make x the subject. So this is the final answer for x coordinate point for P. So it's going to be alpha x2 plus beta x1 all over alpha plus beta. So hence the coordinate point for x in the internal division is x equal alpha x2 plus beta x1 all over alpha plus beta. Now from here we can see that alpha, which is the bigger ratio, is going to multiply the second value of x, which is x2, and then beta, which is a smaller ratio, is going to multiply the first value of x, which is x1 all over alpha plus beta. Now since we know x, we must know for y. So to get y, we just exchange. Anywhere we see x, we just put y. So if it is x2, we put y2. If it is x1, we put y1, just to find the coordinate point of y eternally. So the coordinate point for y eternally is going to be y equal alpha y2 plus beta y1 all over alpha plus beta. So the coordinate point for P, which is xy, which divides 2 points A and B eternally, is, now this is the formula for finding the coordinate point P, or the coordinate point, whatever it may be R, it may be Q. This is the formula for finding the point that divides 2 points eternally. Okay, so let's take our first example. So example 1, P divides the line AB, where A is -1 and 2, and then B is 3 and 4, eternally in a ratio 3:2. Find the coordinate point of P. Now we are told that P divides a line with points A and B eternally. So the eternally must give you the idea that I'm going to use this formula. So once you see eternally in a ratio, so eternally in a ratio will tell you that, okay, this is the formula I'm supposed to use. If they write externally in a ratio, this is not the formula we are going to use. So now how do we solve? Now this is the example. First, you must write out information. We call them data. First, you must write out your ratio. So the first thing is to write out your ratio. So with the ratio, we have alpha is to beta. That is our ratio. So alpha is always first, and then beta becomes the second. So alpha is 3, beta is 2 when you are comparing. Now we have the point. We are given 2 points, point A and then point B. So point A becomes x1 y1, and then point B becomes x2 y2. So if you can write out this data, your ratio, your points, now the next thing is to write the formula, the correct formula for solving eternal ratios. So this is the formula for solving eternal. So we know alpha to be 3, we know beta to be 2, we know x1 to be -1, we know y1 to be 2, we know x2 to be 3, and then we know y2 to be 4. So you just substitute. So we have 3 times 3 giving us 9, and then 2 times -1 will give us -2, all over 5, then comma 3, 4, 12 plus 2, 2, 4 all over 5, giving us 9 minus 2 on 5, 7 on 5, 12 plus 4 on 5, giving us 16 on 5. So this is how to solve similar examples. So we are going to try another example to see if you've gotten the idea, so that I can give you a try work. So now we have example 2. So example 2, we have R divides the line AB. It's always going to be P. So we have R dividing the line AB, where A has a point, B also has a point, eternally in a ratio 2:1. Now the question is, find the coordinates of R. So before you start, you must know the ratio. So we know ratios are alpha is to beta. So after writing alpha is to beta, now you compare what is alpha. Alpha equals to what? Beta equals to what? Then you write. Then after that you write your point. As I am saying it, you are doing it. Then write your point. So this is what you are supposed to get. Now the first point becomes your x1, y1. And then the second point becomes your x2, y2. So when you are done, then you go for the formula for solving eternally. So this is the formula for solving eternally. So it's going to be alpha x2 plus beta x1 all over alpha plus beta for x, and alpha y2 plus beta y1 over alpha plus beta for y. So this is the formula. So we know alpha, we know x2, we know beta, we know x1. Then you input your values accordingly, and this is what you are supposed to get. Your final answer must be 2, 3. So this becomes the coordinates of R, because R is dividing the line AB in a given ratio. Okay, so I have try work for you guys to do. So I want you to pause the video and then you solve. After solving your final answer, I want you to either comment them, or you just, yes, it's better you comment them, so that later when I come, I'll give you the correct answers to each and every one of them. And as you follow the method, writing your ratio, writing your point, and then stating the exact and correct formula for solving eternally, you are not going to make a mistake when you're solving. So I want you to try this before we move to the next. Okay, so we start with external division. Now with external division, is more like using the same formula as internal division, but just that there's going to be a change in sign. So with internal division, we deal with addition, but with external division, we are going to change all the additions to subtraction. So the coordinate point for P, which is x and y, which divides 2 points A and B, external, is so the same formula but just a change of sign. So you don't have to worry yourself too much. So if you can recall the formula for internal, you can only make a change in sign and it becomes external division. So we have alpha x2 minus beta x1 over alpha minus beta, then alpha y2 minus beta y1 over alpha minus beta. Always the beta must be the smaller ratio. Always the beta must be the smaller ratio. Okay, so let's take our first example. So using the same example, so we have P divides the line AB, where A is -1 and 2, and then B is 3 and 4. Externally in the ratio 3:2. Find the coordinates of P. So now we are going to use the same method. We are going to write our ratio, we are going to write our point, and then we are going to beautifully state our formula so that we can easily solve. So now first you have to write your ratio. Now the ratio is 3:2. And one thing you must understand is that the question says we should find externally. So the ratio is alpha is to beta, which is the same as 3:2. So alpha becomes 3, beta becomes 2. So now we must state the formula for finding externally. So external division formula which is alpha x2 minus beta x1 all over alpha minus beta, and then alpha y2 minus beta y1 all over alpha minus beta. So we know alpha, we know beta, we know our x1 to be -1, and then we know our y1 to be 2, x2 to be 3, and then y2 to be 4. So you just input your values, 3, 3, 9, then you have plus 3 on 1, we have 12 minus 4 on 1. So we have 11,8. So the coordinate point for P is 11.8. So if you can identify internal from external, you will not have any trouble when it comes to calculating, because the formula is almost the same, but just that there is a change in sign. So anywhere you see the positive, it means it is internal. Anywhere you see the negatives, it means it is external. So let me give you try work for you to try. So this is try work 2 for external. So now the same, but just a change from internal to external. Okay, so you pause and then you also solve. After that, you give your answer in the comment section, or you keep it. I'll bring the answers later. So our next lesson. So with our next lesson, we are going to continue under the same coordinate geometry 1. We are going to find the equation of a line. We are going to find the equation of a line.